So today, we're not talking about your average home router or anything like that.
No, not at all.
We're doing a deep dive into something a lot more specialized, the Thor Broadcast F-EDFA-16 optical amplifier.
Right, and this piece of gear, it tackles a really fundamental challenge for modern life, really.
Yeah.
How do you send just massive amounts of data over these huge distances without the signal just, fading away or slowing down?
Exactly. Light is fast, but the fiber lines are long, the signal decays.
Mhm.
And this amplifier is the fix. It uses what's called Erbium-Doped Fiber Amplifier technology, or EDFA. But the key thing, the real insight here, is that it does this with almost zero latency.
Yeah, and that's the thing. The latency is practically zero because it's not processing anything.
It's not converting the signal.
Nope, it's just light in, amplified light out instantly, all happening within those specific DWDM spectrum bands around 1540 to 1565 nanometers.
Okay, so in practice, where would you actually use this? I mean, that zero latency feature sounds critical.
It's for two main things, really. First is just long-haul fiber transport, think cross-country. The other is feeding a fiber optic PLC splitter.
Ah, so that's where you take one main line and then split it out to, say, dozens of different endpoints.
Precisely. And it can handle up to 8 of those multiplex channels at once.
And what's really interesting is that it's totally protocol agnostic, right?
Yes, that's a huge deal. As long as the signal is riding on light in that 1550 band, the amplifier just works.
So you're saying it doesn't matter what kind of data is on the light. It could be, I don't know, super high-speed digital or even an analog RF signal.
Exactly. It just sees light and boosts it. The payload doesn't matter at all, which is, fantastic for network architects. No vendor lock-in.
All right, let's get into the nuts and bolts of it, because not all hardware is created equal. The source material really highlights the low noise figure.
Yeah, getting a low noise figure is notoriously difficult in an optical booster. It basically means the amplifier isn't adding its own static or fuzz to the signal it's supposed to be cleaning up.
Which comes down to the quality of the internal parts, I assume.
It does. It requires a really high-quality pump laser and superior components. And they actually mentioned the fiber itself.
The OFS Erbium-Doped Fiber, yeah. It even notes it's made in America.
And all that quality stuff, it translates directly into performance. You get a really strong output power, plus 16 dBm.
But it's also stable, right? The spec sheet says it maintains that power level even if the input signal is fluctuating all over the place.
That's the key. It can handle an input anywhere from megahertz 10 to plus 10 dBm, and the output just stays rock solid. That's paramount for network stability.
Yeah, and stability is everything, especially if this thing is sitting in some remote cabinet 100 miles away. How do you manage it?
Well, it has the smarts built in. It's got a basic SNMP system over an RJ45 port.
Okay, so you can plug it into your network management system. No more driving 50 miles just to check an alarm.
You got it. And for protecting the hardware itself, there's a really critical feature, an automatic signal detect alarm.
What does that do?
If the input signal drops, say a fiber cut somewhere upstream, the alarm automatically shuts off the pump laser.
So the expensive laser doesn't just run dry and burn itself out.
Exactly. It's a feature that protects the investment. It makes sure the hardware is built to last.
So at the end of the day, this little box is basically a silent workhorse, just solving that physical problem of light decaying in glass.
It keeps our data moving fast and clean, but it all comes down to that tiny bit of material science.
You mean the erbium?
Yeah, the entire function, all this high-tech performance, it relies on doping a special glass fiber with a tiny amount of a rare earth element.
So you're basically using chemistry to make light amplify itself instead of using a bunch of complex electronics.
That's it.
That's just stunning to think about. The speed of our entire global network kind of hinges on how well we can infuse glass with a microscopic amount of a specific element.
Yeah, I mean, consider the hidden ingenuity in that. It's about harnessing chemistry to control photons. And that little piece of, specially doped glass, that's the reason you can stream video from across the world without a second thought.